Hello everyone, welcome to this stream. Thank you for having me here. As you might remember on Twitter this last few days, there was some discussion about streams for KiCad development or KiCad Let's Plays in per se. And basically we wanted to have some streaming of me laying out PCBs in KiCad. So this is what we will be doing today. I want to make a small follow-up for the previous stream. So regarding running on the iCEBreaker Litex microcontroller, Sylvain actually together with Scott from CircuitPython and several other people, they worked really hard and got CircuitPython to run on the Litex CPU. So that's actually great progress there. So we have that. We probably need some more work to make it more generic and easy. Oh no, it's MicroPython. Thank you, Sylvain, for correcting me. So it is MicroPython at the moment that works. I assume this is because of the USB interface missing, and we are using just normal serial interface. So thank you, Sylvain, for putting that together. This is pretty awesome. I actually have it still flashed on this guy here, so it is it will be fun to play with. I'm sure we will be making some more streams regarding that, and as soon as there is more progress and we have something that we can essentially provide as a basis, as a reference, we will probably release that in some shape or form. So I assume Sylvain will put that in some repository of his. Okay, so that's the progress there. And today we will be working on yes, there is supposed to be music. There's music in the background. I have. We will be working on the bitsy. Let's see. So this is the bitsy. This is the PCB for the version essentially B. And let me show you the little bit history here. So let's do the desktop here really quick. There we go. So this is the iCEBreaker that you might already know. Let's try to get some focus. So iCEBreaker currently is put together out of the ICE40 UP5K FPGA, and it has flash, and it also has an FTDI, USB to serial or SPI. So we use the MPSSE engine in the FTDI chip, and we can flash the flash chip and put the bitstream in there, or the executable for the core that we have in the FPGA, as well as use it as a serial interface. So all the USB magic is contained to the FTDI chips. If you know me for any period of time, I'm not a huge fan of the FTDI, but there's not really a comparable alternative. A fun fact, this FTDI chip, because how customer friendly and willing to actually help out FTDI is, this chip costs me more than the FPGA on this board. Almost twice as much as the FPGA. So this is quite annoying that FTDI, even though I contacted them and asked them, like, we were making a development board, would you be willing to support this? Would you be willing to expand things? And they were like, no, just buy the price that you find on DigiKey. Your volume is not interesting, not big enough for us to care at all. So, well, what do? Well, currently we still buy their chips. I'm really looking forward to remove that. The problem is that even the chips that exist, so for example, the CP2102 is too slow. It doesn't have the high-speed USB interface. And also, it is not compatible with the interface that FTDI has. So we cannot use it with the vendor chips. So I wish there was actually an alternative, but so far, if we want to retain any compatibility with the official tools from Lattice, we can't go away from FTDI chip. The complete alternative solution, so we could use some other chip, we could use a microcontroller, or we could get rid of it completely. And let's look into a little bit of history of different interfaces. So Arduino used to use, I think, also an FTDI chip in the past. I think they might be still using that still today. But there are alternatives. So this is the Teensy, which is a really awesome Arduino compatible, I think the first ARM Arduino, I'm not sure, but it's from Paul Stoffregen. He is an amazing individual. He actually, this is the best like library supported Arduino that I know. It's knowing how the development and how the stability of the Arduino libraries in general is. This is something I would recommend instead. So you can actually, and it is also much faster. So Teensy is a really awesome platform. So I can really recommend that. And what he's doing, he has an additional chip on this, which snags the SWD interface of the microcontroller, loads a special bootloader into the RAM, and then you can actually flash the microcontroller using that special bootloader that is being loaded from the external. So the cool thing about this, it doesn't occupy any flash and any resources when it is not there. It's only occupying memory when you use the bootloader, and the bootloader is located on an external chip that is dedicated to the function. So this is cool. I also like the form factor. It's really tiny, and so that is another step in this. So let me see, because my phone tends to be it's vibrating in my pocket. I see. All right. So there are other boards that got inspiration from the Teensy, which is, for example, the Tiny FPGA. Tiny FPGA is a really awesome set of boards that even has those weird pads on the back that the Teensy has. So Teensy has this weird set of additional I/O on the back. This is a really cool board. It also is an FPGA, and what Tiny FPGA did is essentially have a bootloader inside the FPGA. So what he did is use a functionality of the FPGA that has a special warm boot functionality. So essentially, you load a bit stream into the FPGA that implements basically it talks over USB. So it implements directly USB in the FPGA and talks to the computer. And through that USB interface, you can write a new bitstream configuration in a new section. Just like on a microcontroller where you would have a bootloader, you can have a bootloader at the beginning of the flash and right after that the application. And the bootloader can either run itself to flash a new payload or jump to the payload. Similar functionality you can do in an FPGA where you have two bit streams. the bootloader starts, sees that there is a valid bit stream, or it is being stopped by the computer to flash a new bit stream, and then jumps to that, reloads that. Oh, welcome, Scott. Yeah. Yeah, we will have to. Yeah, Darkbot PDX, it would be nice to have a online version of it, to have a meetup and actually show and tell. That would be fun. It should be organized. Yeah, Darkbot is one thing that I do miss, and I would love to drive up to Portland and have some Darkbot again, but I think we have to wait for it for a while. Yeah, and if we have Dorkbot in a live streaming format, we can definitely join from different places in the world, which is nice. Okay, so going back to the Tiny FPGA. So Tiny FPGA essentially has two bit streams, the bootloader bit stream, and it can use the special block inside the FPGA, which is called a warm boot, to reset itself and load a different bit stream from a different position in the flash. I think there are several slots for it, but in this case we are using just 2 slots. So another thing that I did is the 1-bitsy. So 1-bitsy is a board with an ARM Cortex M4, and this was essentially meant as a demonstration board for the Blackmagic probe. So if you are trying to see, I had problems recommending people what they should use when they get a Blackmagic probe and which boards to use to try out the functionality of the debugger. At that time, there was most boards that you could buy, or most development boards, either integrated their own debugger on board or didn't expose the JTAG interface. So you could not just take a Blackmagic probe, connect to it, and play around with JTAG with the native Blackmagic probe. So I made this board based on an UAV autopilot that I was making at that time. And so it has the same similar footprint as the Teensy, with additional row of holes because I had more GPIO. And that's the 1-bitsy, and I'm not sure. So, and from that, I was thinking when I was making the iCEBreaker in 2018, that is already a while ago, that there should be also a smaller version of that. And this is the iCEBreaker-bitsy, or iCEBitsy. We should still probably talk about the name. iCEBitsy is not a bad name, I think. So this is the version A, and as you see, I made a little bit mistake here. So the crystal here is, the footprint is upside down. So that is something I had to botch fix in this revision. The problem with this was that even though Luke Valenti is the guy who made the Tiny FPGA, he's the guy behind Tiny FPGA. He made also worked on the USB bootloader, and I'm not 100% sure. I think the FPGA used on this is the iCE40HX8K, something along those lines. I'm not 100% remembering. We could look it up. Oh, LP8K. Thank you. So this was the LP8K, and the difference between the LP8K and the UP5K is that the UP5K is designed for lower power. So it is meant to be in very low power applications. That's why it is being used in a lot of cell phones. And it was obviously designed for specifically that customer, for one customer that wanted to put this chip in their phones. It's actually a very big phone manufacturer that is using the iCE40 UP5Ks in their phones. So yeah, the problem with that is if you lower the power requirement, you also have a slower fabric. So it's essentially the interconnect is pretty slow on this, and it cannot run as fast as the LP5K, 8K. So because of that, we had a lot of issues getting the USB stack to run, because it requires 24 megahertz to run reliably, and so I worked on that a little bit, and then eventually I didn't have much time, so I gave up on this project. So I moved on to working on just the full-size iCEBreaker that has the FTDI chip on it, so I don't have to worry about the USB stack. You should put a 1.35 volt regulator on all the iCEBreakers and the bitsy. Can you tell me? So Sylvain says I should put a 1.35. 50% plus speed. Oh, you mean to overclock the core speed? Okay, yeah, we can talk about that in a bit. Yeah, so yeah, overclocking of the up5K. That's a thing. Yeah, there you go. Thank you, Mike. Yeah, so the iPhone 7 has the up5K FPGA in there, so it is pretty clear that there was a big pull on from one manufacturer to get exactly what they wanted. So I gave up on this for now, but in the meantime, really awesome people. Oh, let me pull that one out as an example too. Where do I have it? What's going on here? There we go. So this is FOMU. FOMU is this really wonderful USB. So this is a really tiny, it's also a, oh my god, this thing is tiny. So this is also an up5K, just in a BGA package. Or no, this is actually, that's Tomu. Why did I pull out a Tomu? This is Tomu. There we go, that's the right thing. That's a FOMU. I saw that something was wrong with that board. LP4K? Huh. It's still a lattice chip. Yeah, I'm pretty sure the up5K is being used in some phone, but yeah. Anyways, so this is the FOMU. Oh my goodness. So I don't have a zoom lens that is good enough for this. So you see this really tiny chip. Oh, we can put it actually under the microscope instead. So here you go. So this is the FOMU. And so this is the up5K, the FPGA. This is the flash. This is the crystal, and then we have voltage regulators. So this is a really tiny board. And Sean Cross and Tim Mansell, so Mithro, several people managed to put together a USB core, and now we actually have two of them because Sylvain also made his own USB stack that works on the up5K. Despite the speed issues, so they did manage to get around the problems of the up5K. So Sylvain made the revision B and sent me one of the iCEBreaker-bitsy. So now, as this came up as a topic, and we would like to use CircuitPython And CircuitPython's requirement is that you have a full control over the USB interface. So CircuitPython wants to have U2F, which is loading, like mounting as a hard disk, and then you can drop a binary on. So this is a requirement for CircuitPython. UF2, thank you. I'm glad you guys are there in the chat to correct me. This is very important. Yeah, I will make way more mistakes otherwise. We want to be able to run CircuitPython, and I'm sure Scott will agree with that. And we would like to make an updated version of the board and bring it more closer to the... So Sylvain found a few additional issues and few ideas what we could improve. And also we learned a few things from the iCEBreaker full size. So today we will try to incorporate some of these changes. All right, so let's see what the chat has to say. If I missed something. Welcome, Jared. Nice to have you here. Alrighty. So let's see. So this is the bitsy. Oh, thank you for following. So let's see. Sublime. I started a to-do list. So this is the to-do list that I made for myself for the iCEBreaker-bitsy. One thing is updating the button. As you can see here, it's like in the quarter. The old buttons were these. This is actually the same button. Let me see. Desktop. There we go. So you see these buttons. This black button versus the white button. So the white button is easier to get, and you can get it from a lower cost source. And this button is a different one that is also used on not the newer versions, on older versions of the teensy. So I just had some. Paul basically had a cut off of a reel that he was giving away, so I used that, and then I used it for a prototype of the iCEBreaker. And the white one, because it has a bigger plunger, it doesn't feel, it's not as sharp on your finger when you're using it. So I like those buttons better. So they are actually advertised as buttons for vape pens, which is somewhat funny. I don't know. Yeah, it's probably just a bigger button, and maybe the force that it is that you need to apply is maybe a little bit lower. Anyway, so I like this is much sharper, and you don't hear it as well. It's more rubbery. This one has a little bit more of a click. I like that. It's more tactile. Yeah. Anyways, so this is one thing we will change. We will correct the CDON indicator. For some reason, my schematic is using a green LED. Interesting thing that Sylvain figured out. When he put this board together, he put for the CDON a green LED, I think. And he found out that the board doesn't start anymore. So let's see. Let's open the schematic. So if you look here, this is the LED to indicate CDON, and it turns out when you hopped up on nicotine. That's a good one. The problem that he faced is that the forward voltage of the green LED is not big enough. So the ICE40 actually is checking the voltage of the output after it pulls it up to check that it booted correctly itself. something along those lines. Correct me if I'm wrong, Sylvain. And if this is dropping too low, the iCE40 will not start running. So you need to have a blue LED that has a higher forward voltage for this circuit to work and this iCE40 to actually start. So yeah, so it has to, the CDUN voltage must rise above the voltage threshold high of the chip. So yeah, we need to adjust this. Should be very simple. What else? We need to replace the normally open jumpers. This is an update I made on the full-size iCE40 or iCEBreaker, and these are these jumpers. Instead of having an open jumper and then having a connection here, PCA demo. Okay, thank you for following. I'm always having trouble reading the names of the people really quickly. I'm not a quick reader. Okay, so we want to replace these with normally closed jumpers to clean up the schematic a little bit. Then we need to do some work on the VPP 2.5 volt. I will explain that in a bit. We want to add an Rgb LED and jumpers. So I will get back to the VPP section at the very end because it's a little bit of a longer story. So what regarding the Rgb LED, if you look on the iCEBreaker, let me switch again to the desktop here. So there is a footprint for an Rgb LED on the iCEBreaker. It is not populated by default. Come in. Thank you for following. We don't populate it. It's to basically save a few cents and also not like charge you for the LED, which not everyone will be using. But the main reason was I did not add jumpers on the back to disconnect it again. So if you want to use this connector for something else than the Rgb LED, you would have to desolder the Rgb LED. So my thinking is it would be nice to actually have that Rgb LED pre-populated because it is a fun demo, and add jumpers that you can just disconnect without having to desolder the Rgb LED. Actually the part number is on the silk screen of the board. So this is the CLX6F-FKC, I think. So that's the Rgb LED. You can find it on these parts can be found on DigiKey. I have a few here, so I should probably put them in the store to actually for people to be able to order them. But just ask in the Discord, Coaster, and I will give you the direct link. I think someone even found a pin and pad compatible version on LCSC, so you could also order a cheaper one from LCSC instead of DigiKey if that works better for you. I'm glad you guys enjoy the music in the background. That's nice. That's why. So a little bit of a tangent. That's why I stopped streaming on YouTube, is because I wanted to have background music and to jazz up the stream a little bit. And as you know, YouTube with their ID content matching is incredibly vicious, and if you stream something, they will just take your stream down if you have background music in there. Twitch is much more set up for that. I think they have some other deals with the music industry, and I am also playing more of a so the retro wave or music is a little bit more niche, so the content matching is not hitting immediately. So that's why I can play a little bit of background music and hopefully make people excited for some of those artists, because I like their music very much. All right. Yeah, so I am on Twitch. I am allowed to play music in the background, and if they do content matching after the stream is over, in the VOD, so the video on demand, they will just cover or mute that section that they matched. It doesn't happen unless I'm just being quiet and the music is just playing plainly. So that's sometimes being muted, but I'm also making a local recording without the music. And so in OBS, I have it set up in that way that the recording to my hard disk doesn't have the music, and then I can upload that to YouTube without the music for people to watch later. So that's the idea here. All right. So RGB LED, I'm not sure I will be using the big one. I think I want something smaller than that. We should look into this. And then we want to add PS-RAM. So another fun fact about the iCEBreaker design is there are RAM, so SPI SRAM chips that come also in SO8 package. So what you can do is solder piggyback an SRAM chip onto the flash chip and use this pad on the side here. This is what this pad is for, and bend the leg a little bit to the side and solder the chip select of the RAM chip to the additional signal. So you can then select between the flash and the SRAM on the same board. So you can do a lot of hacks on. This is essentially the whole history of the development of the iCEBreaker. Is people like Sylvain and many others coming and saying, it's like, I made this bodge wire on this board. Can you just add a jumper so that I don't have to make the bodge wire for it? As long as that was not breaking backwards compatibility, we tried our best to not, that all the versions of the board are compatible to each other, but only add additional functionality and additional hacks. So this is how this chip select, where is the chip select? This guy. So this aux chip select, which is normally closed, is an additional line from the FTDI chip connected to the red LED signal, so that you can, after the flash chip is flashed, and the FPGA loads its bitstream from the flash, you can use the SPI interface and the additional aux chip select to talk from the FTDI chips. Green LED. Green LED? I think it was the red LED. The green LED is the SPI one. Anyways, details. So the aux chip select from the FTDI chip can be used to connect to the FPGA and then stream data over SPI, which is faster than UART, into the FPGA. This is how we are doing video streaming to LED panels through the iCEBreaker. So you take USB, SPI, FPGA to the LED panel, and we use the auxiliary chip select line from the FTDI chips to do that on the same pins that the flash chip is located on. So that's the idea. So that's the aux chip select, but we also have and that's connected to the red LED, and the green LED is connected to the auxiliary chip select for the SPRAM part. So this way you can also add a hack here. I think there's a few more additional hacks that we did. I now remember what it was. It's this selection of the 1.8 volt GPIO. So you can actually switch the GPIO of some of the banks of the FPGA to 1.8 volts, because the FTDI chip has a voltage regulator to 1.8 volts, and we tap into that voltage regulator, and you can swap the bank power supply here. Hey Bob, welcome to the stream. Yes, I am planning to put the big flash chip onto the Bitsy too. So it should be mostly compatible to the big size iCEBreaker. Oh, one day I will. Welcome. Thank you for following. Yeah, so that would be the PSRAM. Let's see what next. Oh, the PSRAM. Oh, the point is, Sylvain pointed out that the PSRAM chip is not the wide package SO8. And the part that the flash chip is in is a little bit wider, and it is a little bit finicky to solder on. So we will try to actually find enough space, which will be fun. I doubt that we can find space on the back here, but to try to squeeze in the footprint for the PSRAM on the back of the board as an extension, so that the user has an easier time of adding it. I probably will leave that for last because that's quite a reorganization there. And last but not least, we need to change the MEMS oscillator on the board. For some reason, when I was designing the iCEBreaker, I was looking, I think, on DigiKey and looking for an oscillator, the cheapest oscillator that we can use on the board. And for some reason, they offered me this part that comes in an SOT23 5-pin package. I did find other manufacturers of oscillators that come in a similar package, but it is not very common. Especially now that I'm ordering more parts and new batches of the boards, it becomes harder and harder to get that part. It seems somehow that either I need to order a full reel from the manufacturer. I did find some from one of those suppliers that have obsolete parts in there, even though the part is not really obsolete. I think they only make the packages on reels if people order the full reel of them. So yeah, I would like to change it to something that has multiple suppliers, even if the package itself might be specific to one manufacturer. It should be something that is this manufacturer stocks at like normally without special order on DigiKey, Arrow, Mouser, or something like that. So we will still stick to SiTime. This part is from SiTime. And we will choose something that SiTime offers more readily. So that's the last to-do that we have for now. All right, so that's... Oh, George, welcome. So, tiny LED matrix. So you want a USB-C connector? No, I don't think I will be doing that. I did think about this, and it is possible. I have a USB-C connector in mind. I will switch to USB-C connectors eventually. I currently still use the USB-Cs, and I had a very good experience with those, like USB-B micro connectors. Sorry. I might switch to USB-C eventually. I have in my cart from LCSC a few parts that are just the standard USB 2.0 USB-C connectors. So there are two types of USB-C connector footprints. One is the one that everyone thinks about, is the USB 3.0. It has additional differential pairs. The connector pins are quite dense. It is an increase in manufacturing difficulty to use the finer pitch connector pads on the board. There is also a coarser connector that has only the USB 2.0 pins. It's still more dense because it has additional signal lines to indicate that it is to do some negotiation. So yeah. So I still am using the micro USB connector. I might eventually move on to USB-C. I personally don't see a real reason for that. A lot of people have micro USB. People still have those cables in many places, and there's plenty of discussion about their reliability. I never had issues with them. I personally have not broken a single one of the micro USB connectors from any of my boards. So yeah. The iCE40 can't use the USB 2.0 high speed. So not directly, it cannot. We can use the FTDI chip and use high speed, and this is what we are using here for SPI. But it cannot do high speed itself. That's correct. Yeah. We might be able to do some high speed stuff if we put a high speed PHY externally. Maybe, I don't know. Might be interesting. And we don't also need USB 3.0, not on the up 5K parts. This is something useful when we move on to ECP5 with SerDes support. Then we can do probably USB 3.0 directly in the FPGA, which will be very interesting. Okay, let me get a short drink here. Okie dokes. So let's get started on this. So what is the first thing we should do is let's update the button on from the full-size iCEBreaker. So I should probably first figure out what the footprint is that I have here. Also, what time is it? Wow, 50 minutes to explain the project. Wow, that took a while. I hope I didn't bore you guys to death with this. But I find this interesting. It's good to have the background of a project before you start. Okay, so we have the button switch tagged. And what is the footprint? Yeah, this is the KMR2 footprint. So let's switch over to the original board and find out what I used there. The eRevision. Wrong. I should open the schematic. There we go. Should just copy this. Yeah, I could actually have two instances of KiCad open too. That would do it. All right. Okay. Let's save this and then let's sync it up. F8. Footprint button switches not found. Ah, right. So I didn't update the library here. Is that possible? PKL button switches not found. Okay. So I might not have updated the no, wrong. Git pull. Oh God. Let me do this for a second. Oh, come on. Yeah, already up to date. Okay. There we go. Should be in there. That's weird. Okay, let's see. Let's look in the library. Footprint library not found. What are you talking about? Okay, something is wonky here. Manage symbol libraries. We have those in here. That's interesting. Symbol, project-specific libraries. There it is. So this should be fine. Chi project mod. ... So going 2 up and then lib, pkl. Should be there. They are here. Why is it complaining? What did you do, KiCad? Let's look in here. Footprint libraries. Oh, they're completely missing. That's interesting. FP table. Why didn't it load it? I have the file here, I'm pretty sure. Version yak shaving KiCad. Oh, why is it not here? Bitsy 2 symlib table fp info cache. Oh, I don't have it here. Interesting. So let's copy it from the big icebreaker. I'm pretty sure I have it. This is before so this is really old design. That was before they had the specific files, the fplib table files. I don't think they existed at the time when I installed that KiCad version. Or when I made that design, they didn't have those yet. Let's see if it will now load. Footprint libraries, still not. So probably I have to restart the whole thing. Let's see if it will do it this time. Is the URL correct? Yeah. Manage footprint libraries. Yeah, there we go. Now it's loaded. Okay, good. Well, it is, they are revamping. So my take on the whole KiCad library stuff is they are breaking things to make things better. So I'm willing to struggle through this for seeing things improve. So that's my general take on the software I use. I prefer using open source software if the trajectory is there. KiCad has the trajectory of improving things. That's why I keep using KiCad. And it is moving forward very fast and very nicely. And as a counterexample, that would be Gitter. Gitter doesn't have a good path forward into the future and improving things in a way that I find useful to me. So that's why we are not using Gitter, we are using Discord. So yeah, that's my take on the tools. If there is an open source solution that has good trajectory and is making genuine improvements that are, in my opinion, most useful, then I'm happy to support that project and keep going. But not if the developers have weird ideas about what is important. Okay, so let's see if we have that now. Let's see if this, yeah, there we go. Now it loads. Perfect. Okay. Cancel, then F8. Keep existing symbol to footprint association. Change footprint, this one to this one. That sounds about right. Update and close. And let's see. Yeah, it's quite a lot bigger now. So all we need to do is move this guy a tiny bit to the right. I'm not concerned about yeah, that should be. I'm not really concerned about the silkscreen stuff at the moment. We can deal with that later. Yeah, for example, I can move it off the board too for now. But yeah. There we go. Like this. And then we can remove this and reroute this. Make it nice and clean. I'm usually using my laptop for designing, so I use a normal keyboard usually and not the nice typing keyboard from so yeah. Oh, there's KiCad library util. Yeah, there are some good tools for the KiCad library management. I did submit recently a collection of parts. It was doable. I have to say, I really hope the KiCad people will do some cleanup of the generator scripts. There's a huge pile of dead code and dead scripts sitting around, so you have to swim through an ocean of scripts that are obsolete first before you find the most up-to-date one to generate the footprints that you want. Also, they are not like auto-generating when they update things. It is not pulled into a continuous integration system. There's not a database of central like coordinates. There's a lot more work to be done on the library end when you want people to contribute to the project. It took me well over a week to wrap my head around how they want this stuff generated and then submit it, make a pull request, and it's like, and then get it merged. It is possible. It is definitely way better than it used to be, I think, especially because you don't do one-off footprint generation and then submit it, and then there's more generation and more scripts, so the situation is better. But the current way they are managing the scripts, it's like some third-party person that made a script way at some point is now maintaining a scripts not under the umbrella of KiCad. It's in a separate repository. So I think when they migrate to GitLab, the libraries, then they will probably merge that together into one project. But there needs to be someone responsible for how this script architecture should look like and actually do some opinionated work on this, where it's like, no, we are doing it this way and not just random way, and be a little bit more militant about how the footprint generation scripts are. So this way, people that just, oh, I just need to update these footprints specifically, have much more guidance. This is the right way to do things. This is how I will submit it. And then also the maintainers will have an easier time of reviewing the changes if it is just one way to do that. So yeah, that's my take about the current library situation in KiCad. That said, the libraries themselves made huge strides, and they are much more usable than they used to be. So it's really, really much better. And I gain more and more confidence in actually using the upstream library footprints than I used in the past. So yeah, it's like use the generator scripts. That's the right thing to do. And then you don't have to change everything by hand 50 times when the standards change. All right, so that's the user button. That was pretty easy. So let's save this and let's, was it Alt-3? Yeah. So this is the 3D model. Oh, I don't have a 3D model for this. Yeah, that's not a big deal. But yeah, this is the new button. That was easy to change. So we can tick that off our to-do list. So that's done. Jared was asking about the Sublime Text checkmark to-do thing. It is simple to do, I think, the plugin. So that's what I installed. Simply to do or simply? Let me check. I knew I should have left that. Plain tasks. That's the plugin. Plain tasks. So there you go. Correct the CDON indicator LED to blue. That's very easy. Let's just change the color in here. Blue and blue. Okay. So that should be easy. Now we can update it. Cannot remove and Why is it changing these? Connect X1 pin 2 to net. Why is it changing nets here? Single pad net. Well, I hope this will not break things. So this is the blue LED. Oh, this is the CDBU. Okay, so that should be updated now. Yep, so this is blue. And it's on the fab layer. Perfect. All right, so that's done. Then replace normally open jumpers to normally closed jumpers. So this how was that? Yeah, so we can just go in here, PK on MISC, and use the normally closed jumper. Jumper, PK jumper normally connected. There we go. So that's closed. We can then remove this guy, because then like this. So that's the second jumper. What do we need else? This guy needs to be changed. So the advantage of that is now we have two separate nets. So how these, oh, we also need to change the footprint here, right? So this is the 0603 and we need the 0603. And because it's a power one, so I have these footprints which have different paths to connect in the center here. This is the 0.15 millimeter, 0.2 millimeters, and 0.3 millimeter wide traces that connect those two paths. And this is done by a workaround inside KiCad where you have two paths. So maybe I can, after I replace it, I can actually show you. So in the footprint editor, PKL MISC, and then, no, it is a PKL jumpers, there we go. So we have two paths and then we have this graphic. So this is actually a graphic element which is on the copper layer. And this is not really legal in KiCad. KiCad definitely complains when you do a line like this, you draw something, and then you switch it over to copper layer. Oh, it doesn't complain. It used to complain. But yeah, it's quite a workaround. Yeah, welcome to the stream. Thank you for the follow. So this is how you can make an object that is electrically connecting, but will not, it used to not cause issues with DRC, but I know now that I think they changed a few things. So this is now causing issues with the DRC. Why is it not deleting it? Why can't I delete it? Shift backspace, what? Weird. Okay, so yeah, the PKL libs are mine, yes, and they are in on my GitHub. So this is how you can work around to have a connection between two nets without having the same name for those nets. And this is how I do it. And also I add here in a mask layer, so to open the mask. So between those pads, there's no masking from the PCB manufacturer. So this copper is exposed. I might have an example how that looks like. If we look here, let's see, microscope, there we go. There you see it. So these are normally connected jumpers. And you can just take an X-Acto knife, if I find one. You go with an X-Acto knife in here, and you can just split it and remove that connection. Yeah, and this is VA in pad because it doesn't matter, it's just a jumper. So even if you hand solder it, it will be fine. So you just can split it, and if you need to reconnect it, you just use some solder, and then you can make a jumper back connected again. So that's the solution here. Yeah, so that's how I make my normally connected jumpers, and we should update those. I should actually group edit it. Yeah, let's do the group editing here. Let's demo that. Jumper, value. The value is jumper. They don't show the name here, do they? Huh. Interesting. Yeah, the value is automatically. Yeah, we have a bunch of those here. Do all the jumpers that I have are normally closed? That's the question. I think they are all normally closed. I don't think I have a single jumper that is not normally closed. Yeah, even the 5-volt jumper is normally closed. Yeah, so I should, yeah. So I should be able to just do this, and then that's fine. Just replace this. I don't think I can mass edit the symbol used. No, I would have to go into the schematic file itself and replace it as a string inside if I wanted to mass change this. Yeah, I don't feel like doing that at the moment. There are only a few more. Okay, so now we can remove those. Come on. There. There we go. Do we have more? Any more jumpers we need to normally close, replace? I think that looks good. So now that I have also the footprint, I think we can replace them all. Jumpers, just replace it here, and then, and okay. So now they should be all changed. Yep. Yep. Yep, okay, good. So that's fixed. And now we can go in here. The interesting part will be that if we go page down, the back side. So currently there are traces here. And we can remove those traces. Because if I just leave those traces in there and then update the board from the schematic, it will try to rename from two nets the same trace, and things become a little bit wonky. So I rather remove the traces first, and then update the board from the schematic. Yeah, VAIMPAD works in many cases. It really depends on how much you want to risk solder being sucked into the pad. But in case of jumpers that are user changeable and you actually have the control over solder by hand anyways, I think it is totally a valid thing to do to put VAIMPAD there. Okay, so trace removed on those jumpers, so that's fine. And now we can go back and press F8, and we can, this will update things, quite a lot of things. So update PCB and see. What is it doing? Why didn't it? Huh. Meso. It has two names. Interesting. iCEBreaker, it didn't change the name of that signal here. Because this should be iCEBreaker, I think. Let's see, 14, right? iCEBreaker, IO0. Oh, this is because of the slashes. So that's a convention I started using in my boards, but I I didn't realize that this is also a convention for the for how signals are being divided between sheets. So if you have a schematic sheet and you have a signal inside the sheet and you have multiple sheets of the same circuit in there, you're using the prefix to actually say which sheet it is. Oh, maybe you're right that I have to just flip this guy around. Oh yeah, you were right. That's correct. Good catch. And this one, Mozy. No, this is IO, and this is... Right. I should probably do that before updating the board, because then the signals will automatically get updated. Yeah, I'm trying to work around the KiCad machinery a little bit here. So I should probably rotate this guy. Oh, it didn't update in here either. Interesting. Ha 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 ha. Yeah, but the rotation is correct. You are right about that. And then I can change the trace name. 3v3 volts. This has to be rotated too. 1.2 volts. Oh, come on. Oh, overlaying objects. It's like this is something I don't know why it is still not fixed in the stable. Like I cannot select the jumper because for whatever reason this was fixed I think 5 times now how the layer selection is being used. So I don't have anything selected, escape, and then I try to select the jumper. I can select the pad, but if I try to select the object or the footprint, it just selects the front footprint. Like why? Why don't you see that there are multiple areas that you could choose? Something is wrong in the selection algorithm. I have the same issue with like text overlays, and I remember this being fixed at least 3 times now. The same location for the jumpers. Huh, George. Yes, you are right. That's even a better solution. Yes, that's correct. That's a very good point. Let me go back here and then rotate. How did I do this? So this was Flash Mozy and Miso. Oh, I can't. The problem is this setup with the jumpers that I have here is a very special one. So if you want to flash the flash, so this is something. Oh, Timon, welcome to the stream. It's nice to have you here. If you want to program the flash, you from this header. So this is an additional header. You don't necessarily need the bootloader to program the bitsy. You can also use these pins here. And if you want to not change the pin out on here, you can do flash the flash chip or disconnect the chip select from the flash chip, disconnect those jumpers, connect them vertically instead so that flash Mozy is going into the iCE40 Mozy. And the ice for and the same thing with Miso, and this way you don't have to change the pin out here for the Miso and Mozy lines. You still have to disconnect the chip select in any case, but this is something the dev boards have. So so the official Lattice dev boards also have. You can have jumpers and you swap it if you want to flash the flash or directly put the bit stream into the FPGA, bypassing the flash completely. So it is a, I think they call it in the datasheet the passive programming or something. So the FPGA doesn't actively load its bitstream from the flash chip, but you as a user are pushing it from a PC. So yeah. Oh, Captain Morgan, you should get another beer. I'm pretty sure that's important. I will have a sip of water for that occasion. Yeah, there we go. I don't think I want to rotate this. I think I want to keep it this way and make sure that, yeah, these should be correct. So the problem here is that the signal names are a little bit off. So this should be the I/O. So this pad should be connected to the FPGA, correct. And this pad should be connected to the FPGA, correct. And then these should be connected to the flash chip. What's going on here? So this is the resistor. Then we go up. Oh my God, this is all crazy. I have the feeling things are a little bit off here. Oh, I/O 0. Ah, there we go. So that's correct. I/O 0. So this goes... sigh. So Mosey. I'm not sure I'm doing this right. So 0 and 1. And then the ICE40. That is correct. Yeah, I could just remove everything and then redo it. I'm just trying to wrap my head around what should go where. So we consider on one side, I think, the programming and the flash chip as one side of the equation, and the FPGA on the other side of the equation. And so we keep in line the pins that go to the FPGA, to the flash. So flash and the programmer should be on one side. That's fine. And we should definitely iCEBreaker rename this. So this one, we should definitely rename these. Oh, that is so wrong here. So this goes to the FPGA and then somehow ends up on the flash. Okay, this is some... I think this was wrong in the first place on the board. I think I did it wrong in the first place. That's what I think happened here. So this is wrong. This should go through the jumper. And then SCK, where's the Mosey? This one is completely disconnected. Oh, what? Wait. No, it is connected. But this is connected to here now. iCEBreaker. So this should be iCEBreaker. So this is why you want to have them separated. Yeah. Anyways, I need a very short break. I'll be right back. All right, and I'm back. So let's see what happened in the chat. The feature for SRAM programming is almost useless in the bitsy. Yeah, you're right. You can just swap the dampen header. Yeah. Yeah. Maybe we should just get rid of it and just do that on the. The problem is the chip select for the flash, I think. Oh no, not true, because we can keep the FPGA in suspense. If we wanted to, so I think we still have to keep the jumper from the programming header to the, yeah, we need to leave the chip select in there. But this would actually open up additional space on the back of the board, which we definitely need if we want to put another, the RAM chip on the back. So this is actually not a bad idea. Yeah, so let's do this. So let's cancel this one. And, oh, sorry, that's wrong. This is done, but we need an additional to-do item. And this is remove slash we don't really need them, as we can just swap the pins on the programmer. Famous last words. Yeah, so let's do that. So this guy, miso, we should probably, I should also fix the naming here. It shouldn't be slash, it should be probably like dash or something, because otherwise the naming is really screwed up. So we can delete this. Come on. Why is this? Oh, I need to use delete. I see. So that's done. The back. Is it Windows? No. So why would we use a backslash? No. You're probably right. I don't know. Yeah. Let's move this. Okay. Maybe I can use backslash. Let's try this. So let's first. So miso. I shouldn't have done that because I now don't remember which one went where. Let's see, just really quick. So it is Mosi goes to miso and miso goes to Mosi. Okay, okay. There. So let's try backslash. Okay. Should probably find and replace them first everywhere. I wish there was an option. I would assume that there is. Why is the highlight still not here? It's like KiCad added the ability to, when you click on something, to highlight things, I think. But it's still not doing it for me, at least here. And I don't know if it is like a setting issue for me. That this is, because this text is selected now. But it's not showing that it is selected because they were messing around with the selection indicator rendering, whatever. Yeah, that's not a problem. It's just a joke. Use the operating system that works for you. I like Linux though, so. There we go. Let's see. And let's fix it here too. Hope I did the right thing here. We'll see. Okay. Save and F8. Let's see what it does. So this deleted it. Ah, yeah. See, now the full name is here. You're right. Yeah, let's do the backslashes then, I guess. It does highlight for me in 599. Yeah, so that's the nightly build. This is not the nightly build. This is the stable. The stable doesn't highlight. And I didn't really want to go to nightly build yet because they are like right about to add the new schematic file format, and this will just very shortly explode probably, so. Yeah, I'm sure the stable release is overdue anyways. So there's a new stable release that is being worked on. So Wayne Stambau, he said that he is working on the new release. So we will have a new stable fairly soon, I'm sure. Yeah, so that's I'm sure this will be fixed there. There are some blocking bugs in the soon to become stable unstable builds, so there are some that they have to fix before they can make a new stable release. So that's, I saw that in issues the other day. So yeah, so we fixed this. I hope I fixed it everywhere. So now we can just fix this here. Up. I didn't mean to forward. That was good track, actually. I'm flailing a little bit on that keyboard. So, wow, Peter, come on. What are you doing? There we go. That's fixed. Now let's, so Miso should be here. Okay. This should be Miso. Okay. Then the other ones should be keep getting connected. Ah, yeah, I have to fix these. What are you doing? Cancel. There we go. That's okay. We have the 4 signals, then SCK, ICE-SCK, ICE-SCK, ICE-SSB, ICE-SSB. Yeah, so we will be disconnecting this and then swapping these on this connector if we want to program the SRAM from the programmer instead of the flash itself. That makes sense. So this jumper stays. Then we have 1, 2, 3, 4, 4 signals for the flash, and then chip select and clock. Good. And then we have C done and C reset. C done and C reset. That's fine too. Okay, cool. And let's update that. Update PCB. Close. So that should fix it. We can actually now just we probably want to reroute this whole stuff here. We should probably clean this up and reroute. This chip select is fine, but I'm not sure where I will put the chip select jumper. So let's just delete this stuff. Yeah. IOB. Because I'm sure we can do this cleaner now that we don't have these jumpers here. Where does it go? Like this. Okay, cool. That's quite a tree here. Okay, cool. So that's better. The question now is also what's going on here. Ah, the capacitor here is on the 1.2 volt rail. And then 3.3 volts. There we go. So let's rebuild the floodplains. 1.2 volts. Huh. This is how you find mistakes when you actually make the nets distinct and separate from each other. Fun times. I think I should name the internal power planes power areas too. Give them proper names. Not a badge. Thank you for following. Yeah. Okay, so that's mostly cleaned up there. Let's name those. That's a good idea. VCC IO 2. And then this should be VCC IO 0 and 1. 0, 1, like this. That should be good enough. And then we should name this just VCC, correct? Or iCEBreaker-bitsy? Because this is a little bit more distinct there. Or iCEBreaker? iCEBreaker. Yeah, let's call it iCEBreaker. iCEBreaker-bitsy. It's more descriptive. There we go. Oh, what just happened? I missed it. Someone followed? Yeah, Tuck. Thank you. Thank you for the follow. There is it. There we go. You can't name a net without a... Yeah, in a sense, you're right that it is somewhat annoying. On the other hand, for documentation purposes, when you're looking for them, that's not a bad thing. I know Eagle, you can name a net without putting a label on it. It's... I am split on that. I am not 100% convinced which solution is better. I find like putting a label is a good idea for readability, especially when you have a print. So I'm not sure. Not sure what is the right thing to do there. If backslash is not allowed. Oh. Are backslashes not allowed in names? What is KLC saying about that? Underscore, dash, period, comma, and plus. Okay, sure. So let's do just dashes then. Yeah, there's probably a good reason why backslashes are not allowed. Not having the choice? Sure. Yeah, it's probably better to have the choice. I think it is a more historical thing that the net name is not an attribute of the wire connection objects, and that's why. Yeah. So what you pulled up, so Jimmy, what you pulled up there is the library convention, but that also impacts. So I know that if you have a pad or symbol connection and you don't give it a net name, it sometimes uses those as a naming for that net. So the KLC requirement for what characters to use in naming there does carry over as a good practice for the rest of the naming. Yeah, so there are details in this. So yeah. Tdepsilon? No, wait. What's the name? Td-Sepsilion? Td-Sepsilion? Yeah, well, thank you for the follow. All right, so I think we should change that in those nets nonetheless. So let's finish doing that. Let's do this. Let's do this. Let's do that. Oh, I already did that. I'm sure. Wow. What's wrong? There we go. There, dash and dash. I'm sure there's a less stupid way of doing that. But I'm done now. It's probably faster than me trying to figure out which. It is 4 layers, this board. This board is 4 layers. No, so the inner layers are for power and so let me show you. So this is ground and power. So I think, yeah, this is ground. This is ground poor. And then we have power. So power is also interesting because we have some additional power connections on here. I will have to sort it out after I did the jumper changes. So that has to be fixed. Yeah. Alrighty, so. I should update this. Right. Come on. No. Come on, dude. The PCB, close. There we go. So now, do we have the naming correctly? Yeah, with dashes, so that should be better. It's not as intuitive because slash is like a more commonly understood OR operator in naming, but this is what we are stuck with. There we have the names. Good. So that should be nice. I will not route it yet because we need to make the other changes first, I think, before we start cleaning things up. Okay, so let's go to the remove programming. Yes, so that's done. So let's move this guy. Oh God, let's move this guy to the bottom. like this. RGB LED footprint, replace MEMS oscillator. So RGB LED with jumpers. So that will be interesting. So I think the RGB LED should go here. And for that, we should use the really small one that is on the hat badge or the Hackaday badge. Yeah, I don't like putting signals on the power plane. That's not what it is meant for. If I need additional signals, so if I really run into issues and I really need to add more signals, I might add 1 or 2 signals on the power plane, but I rather relax the design and go to 6-layer board. But then it's really, I so far, every design that I made, it turns out that I am just not imaginative enough to figure out a routing that would work and not put signals on the power plane. So yeah, it's always a puzzle. It's a nice and tricky puzzle, and like figuring it out without making shortcuts is very satisfying. So I try to do that way. But yeah, if there is nothing else goes, then maybe if this is 1 or 2 signals, there's a reason to do that. But then the board usually is so dense that it might be worth going to a 6-layer to actually clean up the design enough to make it actually genuinely cleaner and not as crazy. So yeah, and 6-layer is still doable if it's not just a project for you as a toy, then just go 6-layer and make it a clean design and save yourself the headache of trying to figure out the puzzle, especially when it is like a work project. So again, everyone does things differently themselves, so it's up to you what you can live with. Yeah, well, it's hard to say. Right, so, we can also remove these guys on the back. Bottom silk. Why am I page? Oh, why is it selected? Yeah, let's go here. B silk. So we don't need. I think we can remove this legend on here, because the only thing that is left footprint front, let's remove those. It will be, come on, guys, please fix the focusing on objects. I really hope this will be fixed in next release. It's really annoying. Okay, so that's done. These should be still indicated correctly. And proc, we can remove that. Oh, wait, we can leave. How do we call this? FCS, like flash strip select or something. Anyways, iCEBreaker. So that's the real name. iCEBreaker. Okay. Move. There we go. For now. Oh, that's on the front. Why do we have... Oh, this is just a legend that I added there. Okay, okay. Okay, so this is the programmer connector, or that these are the marked connectors for the SPI interface. Okay, so that's good. Right. Yeah, you are correct that the power plane is less important than the ground plane, I guess. But I do like having them also closely coupled. It's yeah. If I really have to, I would put a signal on there, but it's never, so far I never had to do this. I rather ripped up the routing, redid the routing, than putting a signal on there. That's how I do things usually. Again, if it is for work and it has to be done yesterday for someone else and I don't care, I would do that. But for myself, I like doing things cleanly. If possible, if possible. Well, time, you take the time. I just take the time. It's not like, oh, I have the time. I take the time to make it cleanly. That's end of story here. Yeah, it's like if you are under the hammer and it has to be done yesterday, I might still say it's like, screw it, I will take another day and send it out tomorrow. It doesn't have to be today. This one day will not save me. Yeah, it doesn't pop up a menu even here. So yeah, let's see. Which version do I have here? 5.15. Yeah, it's 5.15. So yeah. I don't know why it is not working here. I might need to remove the preferences and reload them from defaults. Maybe that's what the problem is. Snap to tracks. Maybe there is some option that is ticked or not ticked. Annotations. Yeah. Oh, Omega Man. Welcome. Thank you for following. Yeah. Okay. Where were we? Because I am now like thinking on a fourth layer here. So we cleaned this up. Let's look at our to-do. Yeah, the RGB LED with jumpers. So let's think about that. So one thing we have to do is, where do we have the RGB? So this is the RGB connection, and we just need to add an LED and jumpers for it. I think that's all we need to do. Let's move this guy here. Can I move this? No. Grab. Yeah, there we go. I don't think I have to move this here. I think I will just make a new RGB LED area here. Or we add it here. That might be the best place to put it, together with the other LEDs. So that, and then we need jumpers. Jumper. And okay. let's see. So these are the normally closed jumpers, and we have the red, green, blue. Tube time! Welcome! Nice to have you here. It's like somehow I managed to get the complete team here from different ends of the electronics and tech Twitter over here. That's very cool. Nice to have you here too. So I guess Adam was managed to create a request where everyone like got the message this time. That's nice. I hope it will be. Oh, nice to see you too. Okay. So where were we? I need to figure out which RGB LED to use. Focus, focus, focus. Do I know what LED was used on the hat badge? There was some LCSC part that was pretty small. So we can look at that. LEDs, dot matrix, just LED, light emitting diodes. I think that was it. And then we need an red, green, blue. Just RGB, here we go. 0402, 0404, no, that's too small. I'm not crazy. Or was it an 0404 part? I hope not. I should probably dig into the hat badge what part was used there. Do I have it checked out here? I might actually have the design checked out here. No, one more. Hat badge 2019. So I do have it checked out. PCB head. Hat badge 2019 PCB. PCB. Get version 2. Oh, that's the older one. That's the red board, because that's what I was doing. Yeah, that's master. Okay, so now I know what I should open. Let's open a new KiCad. All right. Hat badge. Hat badge. And then here we go. Okay. So these are the guys. So these are the footprints. FC. Let's find those. See if this is on DigiKey to be found. Low 5. On DigiKey, that's nice. All right, so this is not even on here. Interesting. Let's do this. Oh, this is an LCSC part. Oh, perfect. Nation Star Optoelectronics. It's a 1010 part. Perfect. Very good. So it's a 1 by 1 millimeter. Tasty, tasty. That will be fun to solder. Okay, data sheet. Specification. Should probably just copy the footprint. That looks very nice. Red, green, blue. 1 and then sync is RGB. Yep, very good. Do you get a different page? Should I go back and see if I... Oh no, this is wrong. This is actually the oscillator page. Let's see if I still can get that page, PG-Key. Yeah, I still can get that. I can make you a screenshot if that's what you want, Drew. There you go. I can send that in Discord after the stream or something. All right. So that's the part. We should probably be able to use a symbol from the standard library. RGB common anode, common, this is pin 4. Ah, I see. That's how the naming is. ARGB. Let's see what the numbering is. It is, come on, where are you? There we go. So it's anode, then RGB. So ARGB is the correct one. Correct. There we go. Oh my God, this symbol is huge. Let's do this way. Why is this symbol so massive? Ugh. So I think what I will do is rotate this and then blue. Yeah, I'm not fitting here anymore. Ah, escape. Like this, there we go, that's better. Red, and then we need 3.3 volts. So we can just connect it here. There we go. Neat. So in this case, with the ICE40, because it has dedicated RGB controller pins, we don't need resistors because you can set the current that the RGB pins here should be set to. So you can control it from the FPGA directly, how bright the LEDs should be. So we don't need additional resistors. All we need are these jumpers so that we can disconnect it if we want to use the connectors, so these pins here, externally from the board. So that should do the job. And we can also add the value here as this part. And then we should look if we can find a footprint. Let's see what does what the footprint is from. Is the footprint in here? Update footprint from library, and this is from the local library, and it has the local footprint. Okay, so we would have to copy it over to PKL or something, or make our own. Should we make our own footprint? I think we should. So let's go. Jumpers, LED. Let's see, what do we have here? Do I have a try? I have the PLCC. We could just copy this one, I think. Discard changes. We don't need these. I think I used to have a bigger dual 0606, dual 0603. Yeah, we can basically, we might be able to base it on this one. Can I just... save as in LED, and then call it 10 try 1010. Let's call it that way, and save. And then we can just go into the 023. So the pads are 0.45 by 0.45. I don't remember how many levels the ICE40 has as settings for the current, but we can look it up, I think. How do you repair? No, that's in downloads. Oh, come on. DC-DC switching characteristic. That's not what we need. That's something regarding the NVCM stuff that we need to talk about later. Rgb Led outputs. Sync current, accuracy, selected current. Among three outputs. The matching is set, so that's the specification. Oh, 12. Okay, Sylvain knows it by heart. Okay, so yeah, 12 levels. Yeah, it is very, very nice and handy, and I'm sure it is useful also for other things, not just RGB LEDs. So yeah. Okay, so where are we? 045. 045. And we should make it rounded rectangle while we are at it. Oh, this is the wrong position. No, 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 no. It's not what we need. We need to change this for 5. And that rounded rectangle. Now we can copy. Is that correct? Is that in inches by any chance? No, unit is millimeters. Okay. That would be 0.45 inches. Woo, that's a big LED. All right, so pads, copy pad properties. Now select this, this, and this. And pads, paste pad properties. And then we should also number them correctly. 1. Oh my goodness. So I don't think we should have this. We should just have one of those. I will move this away for now. And we should move these. So this distance here should be 0.32. What do we have currently? That's much bigger than that, 0.4. So 0.32 would be 16 plus 4, 5. Let me get a calculator. I could calculate it inside. Oh, I can calculate it inside KiCad. Right. So position is, let's do the positive one. It is 0.45 plus 0.32 and then divided by 2. That should do it. And that's it. Yeah, so this is the same thing here, but minus. There we go. How do you measure in KiCad? Just with this tool here. And you can go on the grid. That's how I measure. But I'm sure there are other ways. So usually you can also change the grid to something finer and measure it this way. But yeah, I didn't have to measure. I just could calculate it here. Like this, and then like this. There we go. And now we can also, we should mark which one is the pad 1. And I think the pad 1 is meant to be on the right upper corner. That's usually not the standard for KiCad. I think the left upper should be the, so we should just start here and call it 1. Then 2. It's not the normal orientation there. 3 and 4. And then we should mark pin 1 with something. So we should mark it like this probably. That's the reasonable thing to do. Kwafi. Thank you for your follow. There we go. Like this. That should be reasonable. We could go closer because I'm pretty sure this is this opening is way too big anyways. Control-Shift-M. Control-Shift Do you hear me now? I muted myself. Did I mute my microphone? Oh, wow. Thank you for the show. Oh, God. Okay. Yeah, this is why, again, I need a dedicated streaming machine that is separate from my work machine. That's, I really need to do that. Oh, God. Support me on Patreon. Da da da. then I can get a dedicated streaming machine eventually. Anyways, all right. So, what was I saying since I used the Control M? Anyways, yeah, I said that I'm adding this this stuff in the center just to be cute. I doubt this will be actually visible on the PCB. Yeah, I would use HDMI capture. So if I have a separate machine for streaming, I would use an HDMI splitter from my work machine to the monitor and one to the capture card. So that's how I would set it up. Yeah. Yeah. So if I use OshPark, this would be visible with the problem is that the naming LPI for OshPark means a very different thing for any other manufacturer. So I'm still not 100% sure what the technique is that OshPark is using, because I have not found anyone else but the US manufacturers being able to do this process. So it's an interesting question what the technology is that actually gets that resolution of a silkscreen. Because if you just do, well, it's optical. Yeah, I know, but this is, if it is optical, everyone else would use a solder stop process, and with the normal solder stop, processes, you cannot stack two of them on top of each other without one peeling off of the other. They don't like to stick to each other, the solder stop stuff. I tried. So it is trickier what the materials are being used than one would assume at first. For example, if you have black solder stop and you try to put white solder stop on top of that, that will definitely peel off. You can use a different color of solder stop, like, I don't know, green, and then the white one sticks better, but it still peels off. So it's, yeah, I don't know what the US manufacturing plants are actually using. And also LPI, for anyone else, like in Asia, for example, means liquid photo imaging. So this is the inkjet printer stuff that is being cured with UV, is also called LPI. So it's not like LPI is a distinct singular thing that exists and describes a specific process that someone else could reproduce. It is more tricky than that. 1000 dpi LPI then. That's better. Okay. Yeah, I can imagine that there are machines that get the really high resolution stuff, and probably not all manufacturers have access to that. That makes much more sense. Thank you, Drew. Yeah, all right. So now the Courtyard we still need to do. And that is 0.25 millimeter from the edge. That's at least the standard that we usually use. I mean, 0.1, we can go to 0.5. So this would be 1, 2, 3. One, two, three. So yeah, this silk screen here, I need to squeeze it in harder. I don't really want it to be outside of the Courtyard. Oh, right. Did it just go? There was some standard in JDEC for this, but I'm not sure. I know that they changed it for 2-pin footprint. So for 2-pin, it would look like this and have yeah, there we go. It would look essentially like this. That would be a 2-pin polarity descriptor. But I think for a 4-pin one, it should be just the corner. That should be marked. But I'm not 100% sure. I would have to find that document again. Yeah, that should be good enough for now. There we go. There we go. Yay, okay. Sweet, okay, that's enough. Now, let's edit this guy and add a footprint. And the footprint should be in LED. Oh, I made a copy of this one. Oh, it is try. I already have this. It's the same thing. 0404. Why is it 0404 here and 1010 there? Are they big different sizes? Maybe they are. All right. That should do it. F8. Annotate, yes. And then update PCB. Close. And we have some more additional parts. So these are the jumpers. And then wow, the jumpers are so much bigger than the RGB LED. Let's see how far. Oh, now the jumpers also need to be connected to. Oh yeah, so this is the RGB stuff. These are the RGB pins. Yeah, we would need to go around here. Probably something like this, all around. Get the jumpers on the back here and put the RGB LED here, for example. That's an option. Either here or here. We still have space here. It's just the silkscreen stuff is in here. Yeah, that should do it. And I will put these on the back. So flip, then move. Okie dokes. So I added that. Yeah, the exact placement and routing, this I will do it in one big go. I should check what the time is. Yeah, we are 2.5 hours in. So I think this should do it for today, because I try to keep my streams to 2 hours roughly. And we will get back. Come on. Where are my... Oh, come on. There we go. And... there we go. Okay, so yeah, I am trying to keep my streams to around 2 hours. We can mark this as done too. So the RGB LEDs with jumpers are added. What we still have left is add the PSRAM footprint on the back. So essentially we just add it and then see if we can make it work with the routing. Then we need to still replace the MEMS oscillator and replace the VPP 2.5 volt. So before I go, I will also explain what this deal is with the VPP 2.5 volts, just to wrap things up. So we need to be aware that this circuit or very similar circuit was in the datasheet or was in the dev boards from Lattice. And it turns out no one at Lattice actually tested this, and it doesn't really work. So so first, what does it do? We are trying to provide 2.5 volts to the circuit so that we can program the NVCM, so the non-volatile configuration memory, which in the iCE40 is implemented by eFuses. So you have a big chunk of eFuse memory that is one-time programmable and can keep your bit stream. Then you don't need an external flash, but you can only program it once. That's not strictly correct. So I heard rumors, and this is, I don't have it 100% confirmed, that the bitstream loading circuit, it actually skips completely fused bytes. So I'm not sure if it is fusing to 0 or fusing to FF. But whatever the one is, it will skip those bytes until it hits something else, which is a header for the bitstream. So, and the iCE40 UP5K also has more fuse bits. Again, that's a rumor. I don't have it 100% confirmed. That is big enough that you can fuse a few bit streams before you run out of fuses. So that's something that is not documented, but I heard from a few people that this is the case, and you could do that and fuse new streams a few times. Oh, Dara, thank you for following. So this circuit is necessary, or the VPP 2.5 volt is necessary to have the internal boost circuitry that is generating 17 volts. I'm not 100% sure again, but it generates internally high voltage to do the fusing. But it can't be 3.3 volts, and it can't be 1.8 volts or 1.2 volts. It has to be in a more specific range, but it also requires quite a lot of current. So someone at Lattice, when they designed the PCB, was, oh, I can just add a Zener diode to drop from the 3.3 volts down to 2.5 volts and use that as a supply for the NVCM when you are trying to program it. But it turns out that this cannot provide enough current, and it just drops the voltage too fast, and this doesn't work. So my excuse is I just copied it from Lattice, but the non-excuse part is I didn't test it because I didn't want to just throw a bunch of iCE40s. Yeah, we didn't have an opportunity to test that before we put it on the iCEBreakers. So the solution for now is to actually just remove the circuit and just add a jumper so that you can provide your own 2.5 volts to the circuit, and if you want to program the NVCM. It's not very useful on dev boards like this, obviously, because usually you want to be able to change your bitstream many times. But for some people that want to prototype a solution that uses NVCM and use the iCE40 as a single-use specific purpose device where they want to save money on the flash, this is an interesting solution, and it is important to provide that functionality on the dev board. But not this way. That doesn't seem to be working. At least that's the information I got from Lattice later, that this circuit, so by the way, this circuit doesn't actually work. So we will be removing that and try to document it in a more useful way. Yeah, anyways, so that's another note for the changes we will be making. And yeah, because it is now way beyond the 2-hour mark, I think we should wrap it up for today. I'm sure we will schedule another stream and continue work on the iCEBreaker-bitsy. Felden, thank you for following. Yeah, so definitely to follow the Twitch, so you will get notified via email and whatnot when that goes live. Follow me on Twitter, I will announce it there. Yeah, and I also post it on Patreon when I plan a stream, and the Discord channel. So there are plenty of channels that you can follow and get notified when things go live. Again, these kind of streams and the time I can take for this is only possible because of people that support the channel by purchasing hardware from 1BitSquared, as well as from Crowd Supply, the icebreakers, as well as support on Patreon. So I really appreciate that. And the people that need a specific shout out is Edward Borden, Jerzy Hacker, Jordi Parky Rodriguez, Sid Price, Kelly, and Tom Keddy. Thank you very much for supporting on Patreon. I hope we can continue making more streams and doing some KiCad Let's Play. Yeah, so that said, if you have been, thank you for watching. Bye!